Alright, so welcome back to our topic 2, no, the continuation of the topic 2 of GE 122 Geodetic Surveying. So last time we have discussed about the introduction about the triangulations, and now we are now down to the steps, no, in the triangulation uh, establishment and densification. Alright, so let us recall the general operations involved in geodetic surveying. So, kani nga figure, no? Ito atong discuss ato ang topic 1. So, the general operations involved in geodetic surveying includes the planning, fieldwork, and the computation. So, in triangulation, ma-apply gyapon ni siya, no? Start sa planning, tapos during the field, and how it was computed. No? Ato po na i-discuss karon sa steps in triangulation. So, first thing in the steps of triangulation work is the planning. The planning involves reconnaissance of the selected of the station locations. Kung ahanap to ibutang, ata mag-put o triangulation station. And in field works, so nanadiri ang measurement of baselines, measurement of check base, erection of signals and towers, measurement of angles, and astronomic checks. And for computation, this involves office computations, no? Reduction to sea level, and determination of the x and y coordinates of the triangulation stations. So let's first discuss the reconnaissance and selection of the station locations. In reconnaissance and selection of station locations, this involves selection of the suitable pattern. So, manakong na ganyan niya nga, kung asa na to siya ibutang ang atuang station location. For triangulation systems, select the triangulation station which would best fit the topography of the area and meet the requirements of the survey. These activities can provide estimations on the amount of fieldworks to be done and the usefulness and accuracy of the triangulation systems. So the activities involved in this reconnaissance and selection of station location are initial study using the available maps. So before tamo ato sa field, mag-research mo man gid tanong. So unsay naa available maps, previously gathered survey information, aerial photographs, no? And etc. Next are the lines. Lines are drawn between the proposal triangulation stations, and a study made, no, of the strength of proposed triangulation networks. Such as, for example, unsang strength of figure ang atong gamiton, or unsang atong i-calculate daan ang strength of figure kay para ma-determine to kung dapit ay na naman tayo gi-propose nga location for triangulation station. So ato na din mo compute ang iyang strength of figures. And this the actual inspection of the area, kung ato abang napili sa on maps, no? Kung okay ba siya sa field. Next is ang information to be gathered during reconnaissance is the selection and location of baselines and check bases, and the type, height, and construction of signal towers. Kay sa unang panahon kay wala pa may GPS, so katong mga signal towers pa lang ginagamit para visible, no, makita ang tanan nga makita nimo ang from one station to another station. Accessibility and permanence, no, of the triangulation stations, intervisibility of course, and the number of stations and their descriptions. Next is an determination of size and shape resulting the triangles, and the number of angles to be observed. So kani ang mga kinahanglan nato makuha. And lastly is ang estimates for the amount of clearing to be done. Pag dili makita, intervisible, tapos mo oray pinaka-suitable. So amount, no, sa pagpa-clearing, no, makita ang para ma-intervisible na ang duha ka stations. So important in the reconnaissance and station locations, a careful reconnaissance, no? Careful reconnaissance of the area should be made to be able to plan and design an optimum triangulation network for a given project. So this must be important ato ang i-take note, no, kung magbuhat ta og triangulation works. So a well-planned and effective design system will significantly reduce the survey cost. No, kung ready na ang tanan sa survey, of course, mo reduce ang ato ang magasto. Speed up the measurements to be made tungod kay nakaplano na ang tanan, igo na lang i-execute, so mas dali, paspas. Let's go now to the measurement of the baselines. For measurement of baselines, no, when we say baseline, together with the angle measurements, define the shape and the strength of the triangulation system. So, may tag baseline, again, na itong i-discuss, is ang kanang thoroughly measured, no? Dapat precisely measured siya, accurately measured, kay mo na siya ang diba, sa triangulation kay dapat na kay two angles and one, at least two angles and one measured ng defined or determined ng line. So, kani si baseline is ang katong di-measure na to, no? Before pa lang sa triangulation. So the ideal site for a baseline is an open, smooth and level ground, no? Ideal na siya, ideal. Anang open space siya kay pag kintahin mo gamit ka og aerial photographs, no, or satellite images, makita siya dayon, no? Then smooth and level ang iyang ground. So the ends of the line should be intervisible. So kay open man siya, no, dapat ang duha ka end point, no, sa imuhang baseline is very intervisible. And all obstruction might affect the accuracy of the measurements should be removed. So inga na siya, no, ang baseline. The measurement of baseline should be measured as accurately as possible by using kung kintahay pag mag-measure na to og baseline, pwede kani nga mga devices, like for example EDM or electronic distance measuring devices such as total station, theodolite, no? Or it can be standardized invert tape. And the measurement should be made precisely forward and back, so balik-balik siya, dili na siya kasa i-measure, no? Para makuha gid ang iyahang pinaka accurate, no, nga distance. So dili man siya kasalang, so kuhaan siya og mean nga length, tapos katong nga length is dapat moto siya ang gamitan. Long baselines will provide more accurate distances within the triangulation network, and if a short baseline has been used, a strong figure must be selected to expand it to fit the triangulation system. So nabantayan ninyo, class, nga sa triangulation, sa mga figure nga gigamit sa triangulation, kung sa triangulation at triangle ang gigamit nga figure for triangulation, so mas dako gid siya og distance, no, ang iyang baseline compared sa katong chain of polygons and chain of quadrilaterals. It's because dapat strong figure imong gamiton, daghan kag gamiton nga checks, na, or mas accurate imong figure nga gigamit, so mas short ang imong baseline. Or kung short man gani ang available lang, no, pwede suitable for baseline measurement, then dapat strong figure imong gamiton, like polygons and quadrilateral. So for additional activities in measurement of baseline, so a line of levels, or kanang gitawag natong differential leveling, should be run between both ends of the baselines. So kuhaan yun na siya og level kung ang imo bang ground is shall we say level bagid siya, no, same bagid siya elevation, or kung mag difference o nalang manggaling difference, at least dili kaayo dako, no. To determine the difference in elevation between the ends of the line, and the difference of elevation is needed when computing its horizontal length and its equivalent length at mean sea level. Kay reduce man na siya into mean sea level ang imuhang distance, no, the distance. So both line and check base should be arranged such as that all triangles within the system are used in carrying the length of one base to another. So kaning si baseline and check base, again wala akong discuss ganyan, na balik-balik na lang ni siya. So dapat plastado kung ahanin mo ibutang si baseline, o ahapon ka mag-measure og sa imong check base. Again, this will determine, no, kung strong bang imuhang triangulation, or this will be used as checking kung sakto ba, or shall we say, okay ba ang imong triangulation. And preferable suggested is use a central base with 2 check bases at the extremities of triangulation network. So, dapat kung ang suggestion, no, kung mo have, if you having a triangulation network, dapat na kay duha ka check bases at the extremities of the triangulation network. This is to check, no, kung ang imong triangulation system is nisunod ba gyapon sa standards. Alright, so next step is the erection of signals and towers. So again, di pa man jud uso ang GPS before. So this is the paano na siya kanang traditional, no? So dapat magpatindog sa taog mga signals and towers. So nganong kinahanglan man ni siya magbutang pataog signals and towers, sir? Kaya again, para mas intervisible ang imong duha ka station. So later ato ang akong ihatag sa inyo ako'y picture nga kamutang diri sa slides nga unsa siya pag-visualize, usa din ng erection of signals and towers. So first is ang triangulation station daw must be marked by a signal visible from stations from which it is to be sighted. So kung gingon, purpose ni signals and towers is to make the triangulation stations visible with each other. The type of signal will depend on the locality and available materials. Of course, kung hapon tong economically, mas gamay po siya o gasto. So, kung kintahin na kahoy dadto, so kahoy itong gamitan. And taller signals or towers will have to be erected when the area is intervening trees or high ground. So, kung magdepende jud siya, no? Magdepende siya kung ang imuhang triangulation system ay triangulation station is daghan kayo kanang canopies, trees canopies, so mas taas gyud nga signals and towers imuhang buhaton. The large observing tower may be constructed when there is a need for a permanent signal for setting up the instrument. So sa signal and towers class, sa unang panahon dito nila set up ang instrument babaw, no, sa ibabaw sa signals and towers kay para mas ma-visible nila. Tapos na ay flag mo nang gitawag ng signals and towers kay tower siya nga na ay signal pero ang signal nila is flaglets, no, para makita siya nga okay station number triangulation station number 1 is na siya flaglets color blue, no, ingana, no? So ingana ang ilahang signals nga nagpamatuod nga okay sakto ni siya, this is a triangulation station number 1. And this tower should be permit centering the instrument direction over station when measuring angles. So again, man akong ginyo ganina, no, ng mga pictures of the triangulation signals, no? So as you can see na ay different nga setup, no. Gintahay mo ni sa instrument. To have a signal is na siya flaglet sa taas kani, and ang instrument is nasa ubos sa tower, which is directly kuan pud siya above nasa imuhang point pod nga gi-plumb sa instrument. Another one is ang kaning towers, no? So man akong gingon nga si instrument is gi-set up na siya sa babaw sa towers, which mo nito akong ginugay na katong permanent, no, permanent towers kay diyan naman establish ang instrument sa taas na jud siya. So there are types of observing towers. We have wooden tower, bilby tower, and gas pipe tower. For notes, these observing towers are built such as that the structural members that supports the instrument are not used to support the observer. So again, gibuild ang observing towers para ang support siya sa instrument nga gamiton, no. Pang instrument lang gid siya kay dili siya used for supporting the observer. So dili gid siya nga nakalig-on, no. So kung namang galing sa taas ang ibutang nimo ang imuhang instrument sa tower, so syempre mas ang iyang structural nga gamit is dapat mas ligon-ligon jud siya. Pero usually ang kaning mga signals and towers, di ba katong kagaya na kung naasa babaw sa towers ang instrument is permanent siya. So kung permanent siya nga towers and signals, mas rigid or mas ligon siya compared sa kanang normal lang na signals and towers nga murag ang tower lang is i-build lang siya para to put the signals above, no, nga kani nga station is naa siya ing ani nga katumbas nga triangulation station under. An observing tower actually consists of one tower built inside one another. So, siya. Ang tawag sa isa ka tower na naapod siya isa ka tower gitukod sa inside sa iya ha. So, ang tawag na is observing tower. Observing tower. For example, one tower each to support the instrument and the other is ang observer. So, nga na siya, no? So kung gintahay na ay tower para pang instrument tapos naapoy tower pang observer. So ang tawag na niya is observing tower. So this again example sa katong akong giingon nga types of signals and towers. First is ang wooden tower. So ang characteristic ni wooden tower is low cost siya. So mas barato man gid siya compared sa other materials, light and slender, easy to construct, and sufficiently rigid to withstand ordinary storms and strong winds. This consists of an inner tripod to support the instrument, and the other is outer structure is to support the observer. So again, lahi ang tower sa instrument, lahi ang tower sa observer, para dili siya matandog-tandog. And two parts are entirely disconnected, again para dili matandog ang instrument. No, lisod na kung matandog bang galing ang instrument, nanay error. No? Next is ang bilby tower. So bilby tower, iyang characteristic is made up of steel. This is similar construction to those used in windmills. This is designed by G.S. Bilby of U.S. Coast and Geodetic Survey. So, manang gitawag siya, Bilby Towers. Okay? It was designed by G.S. Bilby. And made in sections so that any height or multiples of about 7 feet can be obtained to maximum 126 feet. Consists of two entirely separate structures again. It's because dili siya dapat magparehas hindi siya dapat connected ang para sa observer o para sa instrument. So the outer support for the observers and inner tower for instruments only. These towers can be erected or dismantled by the survey crew, and this is not permanently and can be used as pwede siya gamiton otro balik-balik. After completing the observations, it can be taken down and moved to another station. So, tanggal-tanggal lang siya, ma-dismantle. So, another na pod na station. Next is ang gas pipe tower. So, yung characteristics is constructed entirely of gas pipes. Simple to set up, and components are very portable, and these are going to put together in sections. So the upper part of this structure is built first and hoisted by means of tackles from the ground, and the next section is added until the desired height is contained. So mura siyang sumpay-sumpay yun, no? Alright, so let's go to the next step of these triangulation steps, which is the measurement of angles. Triangulation systems depends largely on how accurate the angles are being measured. So, kung careful ka sa imuhang pagkuha sa angle or magdepende pud siya kung unsa nga method imong gamiton so to measure the angles, it will really have an effect, no, sa imuhang accuracy sa imuhang triangulation nga makuha, no? And for high-ordered triangulation, skilled observers must be employed. Dapat katong kabaludjud, no, sa measurements. Then only precise instruments must be used, no. For example, sa transit, no, ang at least reading niya, no, sa transit is 30 seconds. and pwede pa siya mas gamay, no? Or ma-detect or maka-read ta og at least 30 seconds or less nga measurement kung transit itong gamiton, or pwede pod kaning repeating theodolite. Angle should be observed in multiple repetitions, no? Balik-balikon jud siya to have an accurate angle, no, nga ma-observe. And its most probable value determined. The common practice sa pag-measure sa angle are it is measured by 6 or 12 repetitions. Please take note that the precision in the angular measurements cannot be increased by continued repetition. The best results are being obtained by a deliberate and systematic handling of instrument without having a rush the work or making unnecessary pointings. So, dapat ko andyan siya ka ng skilled worker or skilled ang imuhang observers and naay sakto nga method, no? In this case, pwede siya kaning 6 repetition or 12 repetitions. So, steps to measure the horizontal angles by repetition methods using transit that has at least ang iyang reading is 30 seconds or less. Let's say, no, we will measure the angles for the triangle ABD. Nakama si triangle ABD diribet. Atong ikuhan. Triangle ABD. Kani nga triangle. So ato ani siyang focus lang, kanilang siya. Triangle ABD. So natay gitawag na interior angle kaning naa sa sulod, kani. And ang exterior is ang kaning nasa gawas. So I guess kabalo naman mo ano. And mo ni siya, no? Ang interior angles nga atong kuhaon kaning na sa triangle sa DAB dapat using repetition method gihapon. Ang exterior pud siya repetition gihapon. 6 repetition. Alright, so measuring angles by repetition using transit, no? So mo ni siya ang method nga usaon dining repetition method, no? So this is the process. First is ang set and level the transit over the primary station where the angles are going to be measured. For example, in this case, sa eta siya. So, station eta. It's because ang atong interior angle nga kuhaon is kaniman. Kanino. So, therefore, dito nga, station mag-set up sa A. So, next is release the upper lower clamps. Upper and lower clamps. So, dalatanan ang angle, dalatanan ang vernier, no, kay upper and lower man. And turn the instrument on its spindle until the horizontal reading and index is marked near 0, 0. Then tighten the clamps and turn the upper motion tangent screw until the index reading is exactly 0, 0. So, sa wata na niya class, i-point out na nimo sa katong station kung asa ka mag-start og reading. Then, using the upper tangent screw, imo siya, di ba, ang upper tangent screw is kanang hinay lang siya nga motion, no, sa imuhang plate para mo turn siya until nga makaread ka og 0, 0. So, with the telescope and direction position, release the lower clamp, then back sight at the rearward, no, or leftmost station B. Tighten and lower the clamp and set the line precisely at B using the lower tangent screw and record the reading. Then this reading is the initial reading. So, kung nang i-discuss ganyan na class, muna ito pasabot niya, no, nga, i-more siyang i-set up ang instrument sa A, instrument A, then imo sang i-set ang 0, 0, no, sa imuhang plate, until nga, kung mag 0, 0 na siya, then imo din siyang so, what, sa term, ana siya, or imo siyang i-point out into B, or naka-backside ka, sa imuhang first na station nga imuhang gisaytan, then record that reading. So the initial reading now is 0, 0 na siya. 0, 0, 0. Then for another steps is loosen the upper clamp and turn the telescope clockwise toward the succeeding station. Clockwise from B padulong sa D. No? So clockwise daw B to D, then clamp the upper motion and turn the upper tangent screw until the line is sight at exactly B. So, ano gamit man siya og tangent screw para masaytan yun nato si station D. And record this reading, and this reading is the first reading. First reading na siya. For example, nakuha nimo is 82 degrees and 45 minutes. Record na nimo, muna imuhang first reading. Again, ano tayo initial reading, ano po tayo first reading. Next is, loosen the lower clamp and turn the telescope toward the proceeding station. Go back to B. Then proceed as described in the procedure for the total of 6 times, except that the vernier is reading only after the 6 sighting. So ikaunom naman siya balik-balikon. Like for example, na naka-initial reading din no. Initial reading first initial reading is 0, 0. So i-clockwise nimo na kinakuha nga 82.45. I-loose nimo ang clamp, no, ang lower clamp, tapos clockwise gihapon padulong sa station B, then i-release na pud nimo ang upper clamp, no, upper clamp kay para maka-read na pud kag another reading padulong sa D, no, padulong sa D. So pag man na pod, imo na pong i-lock ang clamp sa lower clamp, no. Madala na pud nimo ang imong reading, release na pud ang upper clamp, wala na pud kag reading hantod sa makakuha ka og kaunom nga reading. So after niya, no, after 6 times mo na siyang gibuhaton, ang ikaunom ra na nga reading ang imong kuhaon. So again, no, balik-balikon na nimo siya ang ato nga proceeding from initial reading padulong sa first reading. Release the lower clamp, padulong point out padulong sa B, tapos release the upper clamp padulong na pud sa D. So kaduha na hangtod sa ikaunom. Ang ikaunom ra nga reading ang imong itali, which is ang 136.45 in our example. Dari ano. And invert the telescope, loosen the lower clamp and back sight at forward station. Then loosen up the clamp and revolve the instrument again and clockwise direction, then sight and reward the station. So muna akong discuss sa gina ko rong balik. And repeat the process 6 times, and the vernier reading should be 0, 0. Nga na siya. And it differs by more than 30, no? By more than 30 seconds. Reject the result and make another set of repetition. Again, pag mulapas na gani ang iyang difference of 30 seconds, na 30 seconds, then reject the result and make another set of repetition, or kanang itawag na to rerun. Alright, so pagkatapos sa interior, sa exterior na punta, na exterior angle. So proceed as in the procedure of A to E, kaya sa ganina sa initial sa interior angle, no? And foresights and reward to station B, no? Kung imong backside is D, karon ang imong na pong reward is ang B, or imong foresight B. So backside kaya D, tapos padulong sa B. Again na sa interior kay B, padulong kang D. So same lagi hapon in closing the horizon, take back sights at the rearward, no, station and foresight on the forward station. And the horizon close must be within 30 seconds, no, to be acceptable. And otherwise, make another set of repetition. So kung dili gani moabot og 30 seconds or mulagpas pa gani og 30 seconds, so rerun, no. So this is an example of a field notes, no, for measuring horizontal angle. At in to ang case, no, kanino BAD, ang interior nato is naa diri sulod, atong exterior nasa gawas. So atong interior is kaning color blue, no, color blue, yellow pal ay blue, color blue mo nang atong interior, atong exterior is ang yellow. So, maraming ganina ato arang gibalik diri. So, yung ang naong sa field notes, no? So, first point daw ko, no, from point B, no? Ang imuhang station occupied is ang station B, station A. Ang imuhang first point, no, ang imuhang backside kumbaga is ang B. Ang imong rearward is si D. So, from B to D, naka-initial reading number 1, kaning number of repetition kani siya. So, naka first reading nga 82.45. Again, B as ang imuhang initial reading is 00 pala klasa, 00. So, first reading is 82.45 And after the 6th repetition is naa kay 136 and 28 minutes. No? For exterior, no, same gihapon sa A gihapon ang imong occupied, then ang imuhang back site is ang B, no? Ang imuhang station B. Then rearward nimo is si B. No? So 0 0 imong initial reading, and first reading nimo is 277.15, and after sa unom ka repetition is naa kay 223 degrees and 32 minutes. So, in computing the mean angle or the most probable value of the angle nga imong gigamit using repetition, here are the steps on how to get the mean angle. First step is you are going to multiply the first reading by the total number of repetitions. For example, for interior angle nga ganina, 82 degrees and 45 times 6, no? Times 6 ka repetition kauno man nimo. So again, in first reading nimo nga nakuha, i-multiply nimo og total number of repetition. So kay uno man tong gigamit mo ning times 6 siya. Then determine the largest multiple of 360 that can be subtracted from the above product. For example, kay anong 360 man sir? Kay since one full rotation again is 360 degrees. So in this case, 496 degrees and 30 minutes is naa siya isa ka multiple of 360. So again, how many or ang pasabotan niya class is how many 360 are there in the product value above nga nakuha nato sa atong first reading times number of repetitions. And then this multiple, no, for example, ang nakuha nato ganina sa above is 1 man, no? May 1 multiple naman of 360 is then added to a final measurement, no? Final measurement nato nakuha is ang 6th reading, di ba? To obtain the value that is to divide then by the total number of repetition. So manira class, 6th reading nato, di ba, is 136.45. 36.45. And para makuha na to ang mean angle is first ato asang i-add ang 6th reading sa katong isa ka multiple nga 360. So 1 times 360, so inganin na ang equation, 136.28 plus 360 is na atin nakuha nga 496.28. 496.28. Then para makuha nato ang mean angle, i-divide lang nato na siya sa number of repetition. Then we can have 82 degrees, 44 minutes, and 40 seconds. So this is now, no, the mean angle for the interior angle, no, sa katong example nga ganina. Ito 40. So para atong masabtan atong balikon, no. So mas para ma-simplify nato siya, ingani ang pamaagi. First is ang multiply ang first reading sa number of repetitions. So 82.45 and 6 is na kay 496.30. After that, you are going to determine the largest multiple of 360. So i-divide din mo 360 pila ka book 360 sa 496, so naatay isa. No? Afterwards, you're going to get the mean angle. So ato tong i-times ang ato ang greatest multiple of 360 into 360 plus the 6th reading. No? So natay 1 times 360 plus 136.28, so naatay 496 degrees and 28 minutes. To get the mean, i-divide na nimo ang 496.28 sa number of repetition, which is ang unom. Therefore, naa kay 82, 44, and 40. Simple na class, dali na niyo masantay. Alright, so sa katupong sa outside or exterior, ato po tong kuhaon, no? So since naatay first reading at 277.15, i-times na siya of 6. Therefore, naatay 1663.30. Kung na to ang multiple of 360, so in this case, naatay upat, no? Upat ka 360 sa 1663.30. Naatay 4. So, i-times ng 4 sa 360 plus ang 6th reading. So, therefore, naatay 1663.32 and 00 seconds. To get the mean, i-divide ra po na siya kung kapila ka repetition. So, atong example is unom siya. Therefore, ang atoa di ay exterior angle is naa siya 277 degrees, 15 minutes, and 20 seconds. So, since kay natapos naman na ito og solve, no? So, harap to siya ibutang ang final na to nga answer sa field notes. So, itong initial reading sa interior is naatay 0, 0. First reading is 80 to 45. And after 6 repetition, naatay 136 and 28. And therefore, after the solving those mean angle, so from the angles nga atong nakuha during sa field, so naatay nakuha nga 82, 44, and 40 minutes. So mga to answer ha ganina. Next is ang sa exterior. So 0, 0 ang initial, first reading to 7, 7, 15, and for the sixth reading natin nakuha nga 2, 2, 3, 32. Therefore, ang ato ang makuha nga mean angle sa pag-solve nato is naatay 277, 15, and 20. So pag ato nang i-add, so that's equal to 360 degrees. 360 degrees. So therefore, naatay closure nga 0, 0. So inga na ang pagkuha sa measuring of horizontal angle by repetition. Alright, so this is important, no, in the method of repetition in getting the horizontal angle. So it is important that the sum of the interior angle, and exterior angle shall not differ 360 degrees, no, by more than or positive negative 10 seconds, no, for an instrument with less count of 30, no, 30 seconds. Otherwise, make additional measurements. So again, pag mulapas kani og 360 or kulang siya og 360, so kung mag-differ na gani na siya og 10 seconds, no, 10 seconds, so you can make additional measurements or mag-rerun ka. Kaya atong instrument such as transit is ang ihamang least count is 30 seconds, no, 30 seconds. Therefore, dapat dili siya mo have a discrepancy of positive negative 10 seconds. Otherwise, make additional measurements. Alright, so why the repetition method are we going to use for angular measurement? No? So, repetition method is used to improve the precision and accuracy of the measurements of horizontal angles. The same angle is measured multiple times. So, ang iya mo kung concept ani is kung kaunom nimo siya gi-measure, no? So, pag multiple times, maybe mas accurate siya and precise, no? Kung balik-balikon nimo siya o measure, no? With the survey instrument rotated so that systematic errors tend to cancel. So, tuyokon siya murag para makalibrate na lang pud ang iyahang error, no, sa systematic or ma-avoid nato ang systematic errors during sa pag-rotate nato sa instrument. And the arithmetic mean of this observation gives the most probable value of the angle. So this is the repetition method. And the precision of measurement can be exceed the least count of the instrument used. It decreases the possibility of mistakes in the observation. Okay, since gibalik-balik man nimo siya og kuha, no, or measure. O nang there is a low possibility that the mistakes in the observation. O gani balik-balik ko na nimo siya kuha, so di na mawala na ang kuan sa mistake. Let's have an example about the repetition method of determining the horizontal angles. So, example number 1 states that from the given field notes, determine the most probable value of the interior and exterior angles of B. So, sa letter sa anata nga kani siya nga angle, no, sa B. And note that all angles are measured clockwise from backside to far-side. So, mao ni ang field notes, no? Station occupied B, observe is C to A, number of repetition, and measured angle. So, ato ni siyang isolve, no? In the next slide. So, first, ato asang unahon og calculate or solve ang interior angle, which is ang kaning nasa taas, which is ang station occupied at B, station B. Ang observe is station C and station A. We have number of repetitions, 1 and 6, and naatay na kuha diri nga angle nga initial reading na 0, 0, 0, and atong first reading is 60, 05, 09, and we have sixth reading na 31 minutes. To solve, balik na sa itong formula na ang ato ang first reading, i-times na to sa number of repetition, which is 6, is equal to 360 degrees, 30, and 54 seconds. Next thing is we're going to get the multiple of 360. So since isa lang, so natay 1 diri ang answer, and kanang 1, which is ang greatest multiple, ato nang times of 360 plus the sixth reading na 31 minutes. So we have 360 degrees, 31, and 00. To get the horizontal, the mean horizontal angle or most probable value of the horizontal angle B, interior, so we're going to divide the 360 degrees, 31, and 00 into number of repetition, which is 6. So we'll be having an answer of 60 degrees, 5 minutes, and 9 seconds. Next is we're going to get the exterior angle na pod, which is kay nasa ubos. So, same na gyapon itong station occupied at B, and we have station observe, si A na pod karon, padulong na pod kang C. So, pa-clockwise na siya. So, measured angle, which is ang initial, is 0 degrees, 0 minutes, and 0 seconds. And we have first reading is 299, 54, 55. And we have the sixth reading, which is 359, 29, and 24. Same process, no? So, ito ang first reading times ito sa number of repetition. So, 299, 54, 55 times 6. We will be having 1,799 degrees, 29 minutes, and 5 seconds. Then, let's divide into 360 para makuha ito ang multiple of 360. We will be having a 4. 360 in 1799 degrees, 2930. Then 4 times 360 plus the 6th reading, which is 359, 29, 24. Then it will have a 1799, 29, and 24. Then ato na siyang i-divide into number of repetition, which is 6. We'll be having a value of 299 degrees, 54 minutes, and 54 seconds. So, na siya. Alright, so much for the measurement of angles. We will going to proceed into the next step of triangulation, which is the computations. Alright, to start, let us discuss first the summary of the required computations under this step. So it involves length computations to determine the best possible planimetric position, such as x and y coordinates of the triangulation station. So diri as a computation nga part, so magkuha ta og best possible planimetric positions such as x and y coordinates of the triangulation stations. Next is the usual steps, which is the elimination or distribution of errors in the field measurements. Ay since di magmalikayan nga magka-error, no, kay naamon jud kasi klase ng mga errors, then that errors will be going to be eliminated or dili man siya ma-eliminate. So it is by distributing, no, elimination and distribution of the errors in the field measurements. Adjustment to satisfy geometric trigonometric conditions, and determine the best possible route for computing the length and sides of the triangles. Next is we're going to do the reduction of linear measurements into sea level for triangulation network that extends over a large area. Kaya dako naman siya coverage, so ato na po i-take into consideration ang curvature sa Earth na. So especially over regions of widely varying relief. Then we're going to compute the x and y coordinates of triangulation stations. So first is we're going to have or explain, no, or discuss the computations on the adjustment of the chain of triangles rather. Alright, so I guess nakaagi naman mo nino sa inyong theory of errors and adjustments, or kung wala mang galing, so we need to discuss this one. So first is the chain of triangles. In the chain of triangles, dapat all triangles of the all the measured angles in the triangle are affected by the errors and measurements. So kabalo man tana no nga every measurement nato na adyoy error nga ma-encounter. And adjustment of measured angles is necessary such that the accurate values are being determined. So kung nato siya i-adjust para ma-attain nato ang accurate values. Then in chain of triangle, corrections have to be applied such that the interior and exterior angles at each station is to be must add, no? Ato silang i-add, then dapat mo equal siya of 360 degrees. The final angles of each triangle must be added, no? And dapat mo sum siya of 180 degrees. Yan na siya. Sa isa ka station, dapat 360, and isa ka triangle is 180. Two basic objectives of this adjustment. First is ang removal of inconsistencies, and next is ang prevention of error accumulation. So these are the basic objectives of the adjustment. So for example, at station A, no, kanin si A, so dapat si angle A, kanin siya, kaning si color blue, kanina A, tapos plus B plus C must be equal to 360 degrees. 360 dapat na siya. So as sa ang triangle ADG, so ang triangle na pod karon nga A, tapos B, ug si G, dapat mo equal siya og 180 degrees. Any value in excess could be an error. So pag sobra or makulang, dapat error na siya. Error na. So there are methods on how to adjust a chain of quadrilaterals. First is ang method of least squares. No, least squares. This is the exact method on how to adjust the chain of triangles. So least squares is the best and most rigorous adjustment method for triangulation system, requiring a higher orders of precision. So exact man siya pagid ang pinaka the best and pinaka most nga method on how to adjust a triangles. So this is based upon the theory of probability, which is ang least squares. Then simultaneously adjust the angular and linear measurements to make the sum of all the squares of the residuals being minimum. Minimum siya. Then residuals are the differences between most probable value and the observed value. So natin makalculate nga most probable value, tapos napod tayo observed value. Ang differences ana niya class is what we call residuals. Next is ang approximate method. Si approximate method is the simple and convenient method. Pinaka-simple, syempre pinaka-convenient. Used for adjusting angles and sides of triangulation system which are of lower order precision. So, dili siya pareha sa least squares na pang higher order of precision. So, kung imuhang gi-attain nga triangulation is higher order of precision, so approximate method is not being suitable for that triangulation. Geometric consistency is also attained by this method of adjustment, and it approximates very closely to the result of least square solution. So, dili man siya kaparehas jud sa least square no nga pang high order jud siya na precision, but the output of the approximate method is very close na no sa least square solution. But again, least square method is also the best method for triangulation. There are two steps of approximate method na gitawag nga station adjustment and figure adjustment. So the objective of the approximate method is station adjustment. So station adjustment na taha. So ang objective ni station adjustment is to make the sum of the angles about each station must be equal to 360 degrees. Okay, since one full revolution is 360 degrees. For example, at station A, so angle ABC, naman si angle ABC. A, B, and C no, must be equal to 360. At B na ay D o C, E. No? And sa C natay F, GH, no? F, G, H. No? Dapat 360 na sila. And sa station D, si I o si J, dapat 360. Siya. And if the sum of the angles both interior and exterior is not equal to 360, pag di daw siya equal, an adjustment is made by determining the differences between the 360 and the sum of the measured angles. Pag dili siya mo equal, ang katong mabilin, mo to siya ang atong gamiton pag-adjust. No? Pag-adjust. Then the resulting difference is then divided by the number of angles about the station. So, mo ni kaganina, kung dili niya siya mo equal o 360, like for example, si A, B, o si C, dili siya mo equal o 360. Ang answer to niya is i-divide to siya no, into 3, kay tulo man sila ka-angle sa isa ka station. Then, ato din siyang i-divide into 3. Ang answer to niya is algebraically added on each angle of this present sa isa ka station. Added algebraically. Pasabot ang negative, i-add mo siya, ma-minus naman gihapon. So, when we say error, no, pagkuha sa error is ang 360 divided minus the sum of those angles nga present in the station. And to get the correction, ang error is ato lang i-divide sa number of angles nga involved sa isa ka station. Adjusted value is then calculated by the measured angle plus or minus the correction. Alright, so let's have an example number 1. Perform a station adjustment at station B if the measured angles are as follows. No? D to be 88, 56, 18, and E to be 271, 03, 32. So, at station B, no? si angle D and si angle E. For the solution, we're going to have a sum of the two angles within the station, which is the angle D and the angle E. No? So, ato nang i-add si 88, 56, 18 of si 271, 03, 32. We're going to have a sum of 359, 59, 50. To get the error, just get the difference between the sum and the 360 degrees. 360 minus the sum is naatay 360 minus 359, 59, 50 naatay nakuha nga 10 seconds. Now, the correction, to get the correction is, ang katong error is i-divide lang nato siya sa number of angles since kay duha man sila, D o E, morning naatay 2. So, it is equal to 5 seconds. Alright. So, para makuha na to ang adjusted angles, no? Atong i-add, kay since positive man siya, no? Atong i-add si 5 seconds sa katong karaan nga value sa D ug E. So therefore, 88, 56, 18 plus 5 seconds is we're going to have a value of 88, 56, 23. No? So i-add ra ni sila. So kana tapos plus kani mga value is equal to kani nga value siya. I guess kabalo naman mo ana, no? So as sa E, no? Si 271, 03, 32, i-add na to si 5 is naatay 271, 03, 37. So mahibaw na to nga tama ato ang pag-adjust sa angle if the sum of those angles D and E must be equal to 360 degrees. So in our case, atong i-add si D prime ug si E prime, which is ang correct adjusted angles, is ni equal siya og 360 degrees. So tama atong pag-adjust. Alright, so let's do the example number 2. Perform the station adjustment at station A if the measured angles are as follows. A to be 45, 30, 18, B 56, 42, 25, and C 257, 47, 26. So kaganina ang ato ang calculate isang station B karon ang station A na sabta. So station A is naadiri si A, si B, and naa si C. Alright, so first thing that we're gonna do for the solution is, syempre, i-add na to ang angles nga nag-compose sa station A. So we have angle A to be 45, 30, 18, angle B 56, 42, 25, and angle C 257, 47, 26. So we need to get the sum of the three angles. So pag ato na siyang i-add, it will come up with a 360 degrees and 9 seconds. Therefore, to get the error, is we need to subtract the sum nga atong nakuha ganina from 360 degrees. 360 degrees minus the sum of 360 and 9 seconds. Therefore, naatay makuha nga negative 9 seconds ng error. To get the correction, again, let's just divide how many angles. So since naatay 3 angles consisting of 3 angles in the station, therefore, negative 9 degrees divided by 3, so we have negative 3 seconds. To get the adjusted angles, let us from angle A, which is 45, 30, 18, minus na to siya of negative 3, no? Negative 3 seconds. So, therefore, natay adjusted angle sa A nga 45, 30, 15. And for B, so same lang, 56, 42, 25 minus 3 seconds, we have 56, 42, 22. And for C, 257, 47, 26 minus 3. So we have 257, 47, 23. To check that if it is, we are on the right process, no, or sakto atong gibuhat, we're going to get the sum of these three adjusted angles. So pag ato ni i-add si A prime, B prime, and C prime, it will result to the sum of 360 degrees. Therefore, sakto ang ato ang pamaagi. So next type of approximate method is the figure adjustment. So the figure adjustment, the objective of this one is to make the sum of the angles in each triangle is equal to 180 degrees. Since di ba ang sum of the interior angle of the triangle is 180 degrees. So perform only after figure station adjustment rather, and uses the values obtained in the first adjustment. So dili ka proceed into figure adjustment if you are not done with the station adjustment. The three angles of each triangle are added together, and sum is subtracted from 180 degrees. And to each of the three angles, 1/3 of the difference is added algebraically. Same lang gyapon siya sa pamaagi ganina sa station adjustment. But this time, so triangle na siya or figure na ang imuhang consider, dili na siya station. It is assumed that both the station and figure adjustment and angles were measured with equal precision. Again, same lang gihapon sa pamaagi sa pagkuha sa error, but this time 180 degrees na siya. 180 degrees minus the sum of all the interior angles. Correction is error divided by 3 if ang imuhang figure is a triangle. So 3 man siya. And adjusted value is equal to measured angle plus the correction. Plus siya kay pag ma-negative man gani ang correction, so ma-minus lang gihapon siya. Alright, so let's have an example for the figure adjustment. So perform the figure adjustment for triangle ABC, triangle ABC, kani siya, no? Triangle ABC. Given the following angles after station adjustment, so natapos na ang station adjustment. Given na ni siya nga natapos ng station adjustment. So we have A to be 45, 30, 15, B 88, 56, 23, and G 45, 33, 22. For this solution, so first we're going to do is, first thing that we're going to do is to add, no? Add the interior angles A, B, and G. So we have the sum of 180 degrees and 10 seconds. To get the error, so let's subtract the sum of the interior angle. So kanina siya, no? Ano siya? So 180 minus 180 and 10 seconds. So therefore, naatay negative 10 na error. No? And to get the correction, So that negative 10 seconds will be divided into 3 since there are 3 interior angles in a triangle. So therefore, naatay kuha nga correction nga negative 3.33 seconds. And this negative 3.33 seconds will be added into the adjusted, will be added to the measured kanino. Ato ni siyang i-add diri So ato na siyang ipang-add dira sa kani nga mga values sa measured. So to get the adjusted value for A, so 45, 30, and 15 plus, since kay negative man, so minus lang yapon siya, minus 3.33 seconds. So we will be having a value of 45, 30, 30, 11.67. For D, same lang yapon ng pamaagi, so we have the adjusted angle of 88, 56, 29.67. So as sa ito ang G nga angle. So naatay makuha nga value nga 45, 33, 18.67 seconds. And we are going to get the sum of these three angles kung dapat ma-equal siya o 180 degrees. So kung ato nang i-add, it will give us a value of 180 degrees. Alright, so for example number 2, so perform figure adjustment again at the angle ACD, AC, and B, no? Given the following angles. After the station adjustment. So tapos na, given nga tapos na si station adjustment. For B, we have this 56, 42, 22. For F is 48, 06, 12. And for I, we have 75, 11, and 32. No. For this solution, so first again, atong balikon kung saan siya pag-solve is we need to get the sum of these three measured angles. So if we're going to add these three values, we will get a sum of 180 degrees and 6 seconds. Next step is to get the error. Error is equal to 180 degrees minus the sum of the interior angle. So natin makuha nga negative 6 seconds. So to have the correction, this 6 seconds is we're going to divide this into 3. So we have negative 2 seconds ang correction. Again, sa kaning negative 2 seconds is i-add na siya diri sa kaning mga values. Now, so to get the adjusted angles is for A, no, 56, 42, 22 minus 2, no? Kaya since negative man siya, so plus negative 2, so minus lagi hapon siya. Therefore, naatay 56, 42, and 20. So as sa D, no, 48, 06, 10, and sa G nga 75, 11, 30 after D applying the correction. So therefore, pag ato ni siyang i-add, it will equal to 180 degrees. Alright, so I guess this ends for the part 2 of this topic 2, no, sa ato ang geodetic surveying na subject. So if you have questions, no, kindly message me through FB page, and stay tuned for the more upcoming parts of this topic, no, kay since taas jud ni siya class. So I guess this is 254 slides all in all in this topic only. So stay safe everyone, and see you for our next video.